I know you have been waiting for me. Welcome to the World Documentary Series, where we bring you education, discoveries, histories, innovations, and developments. In the previous video we presented on how Israel achieved statehood. Kindly hit the subscribe button and like the channel for subsequent series on this platform. I am Brian. This time, I will be presenting on Archimedes' principles. Ever wondered why a massive ship floats, but a tiny pebble sinks? It's not magic. It's science. And understanding this one principle could literally change how you see the world around you. Stick around, because we are diving deep into Archimedes' principle. Hey everyone, I'm Brian, and today we are breaking down Archimedes' principle, not just the boring textbook definition, but the 7 key ideas that make it click. Whether you're a student struggling with physics, a curious mind, or just someone who likes knowing how things work, this is for you. We'll cover what it is, why it matters, and some mind-blowing real-world examples. You're going to walk away understanding why things float, why they sink, and how we can even use this to our advantage. Alright, idea number 1. The core concept. What is Archimedes' principle? Simply put, any object submerged in a fluid experiences an upward buoyant force. This force is equal to the weight of the fluid that the object displaces. Buoyant force is equal to weight of displaced fluid. Think of it like this: when you push something into water, the water has to move out of the way. It gets pushed up and to the sides. The water pushes back on the object with a force. If that pushback force is stronger than the object's own weight, it floats. If the object's weight is stronger, it sinks. And that brings us to idea number 2, displacement is key. This is where it all starts. How much water does your object move? The volume of water pushed aside directly relates to the buoyant force. Imagine a tiny, super dense lead fishing weight versus a huge, hollow plastic ball. The lead weight sinks because its weight is way more than the tiny bit of water it displaces. The plastic ball, even if it's light, displaces a lot of water because of its size, so the buoyant force is huge, and it floats. It's not just about weight, it's about the interaction between the object's volume and the fluid's volume. Now, idea number 3, density matters, but it's not the whole story. We often hear density determines floating. True, but it's a consequence of Archimedes' principle. An object floats if its average density is less than the density of the fluid. Average density less than fluid density is equal to float. Average density greater than fluid density is equal to sink. This is why a giant steel ship floats. The ship is mostly air inside, it's hollow. So, its average density, which is steel plus air plus cargo, all spread out, is much lower than the density of water. That huge volume displaces tons of water, creating massive buoyant force. That massive buoyant force overcomes the ship's total weight. That's the magic. Okay, ready for a curveball? Idea number 4, it applies to gases too. We usually think of water, but Archimedes' principle works for any fluid, including air. Think about a hot air balloon. Hot air is less dense than the cooler air around it. The balloon displaces a large volume of cooler, denser air. The weight of that displaced cooler air provides the buoyant force that lifts the balloon. Same idea with helium balloons, they float because helium is less dense than air. This is where things get really interesting. Idea number 5, buoyancy and apparent weight. When something is submerged, it feels lighter. That's because the buoyant force is counteracting its actual weight. Apparent weight equal to actual weight minus buoyant force. Your apparent weight is what you feel it weighs. It's your actual weight minus that upward push from the water. This is why divers can lift heavy things underwater that they could never budge on land. The water is doing most of the work for them. Now for idea number 6, real-world applications, beyond ships and balloons. This principle is huge in engineering and design. Submarines? They control their buoyancy by taking in or expelling water. We use it in designing life vests, calculating how much cargo a ship can safely carry, its displacement tonnage, and even in geology to understand how mountains and tectonic plates float on the mantle. Seriously, from the smallest boat to the largest aircraft carrier, it all comes back to this balance of weight versus the weight of the fluid displaced. It's fundamental. And finally, idea number 7, the Eureka moment. Legend has it, King Nero II suspected a goldsmith had cheated him, mixing silver into a gold crown. He asked Archimedes to figure it out without damaging the crown. Archimedes was stumped, then stepped into a bath, noticed the water level rise, and realized this was the key. The volume of the crown would displace a certain amount of water. If it was pure gold, it would displace less water than an equal weight of silver. He supposedly ran through the streets shouting, "Eureka, I have found it. Eureka." He could measure the volume by the water displaced, compare it to the weight, and check the density. Problem solved. It's a classic example of applying a scientific principle to a real-world problem. So, there you have it. 7 key ideas about Archimedes' principle, the buoyant force, displacement, density's role, its application to gases, apparent weight, diverse engineering uses, and that famous Eureka story. It's not just a physics concept, it's everywhere. Archimedes' Principle, the discovery that changed science forever. What if one of the greatest scientific discoveries in history began inside a bathtub? A simple observation. A splash of water. A moment of sudden inspiration. More than 2,000 years ago, a brilliant Greek mathematician made a discovery so powerful that it still shapes modern science, engineering, aviation, medicine, and even space exploration today. His name was Archimedes, and his discovery became known as Archimedes' Principle. The law that explains why ships float, why submarines dive, why balloons rise, and why objects appear lighter underwater. But the story behind this discovery is even more fascinating. It is a story of kings, crowns, genius, science, and the legendary cry, Eureka! The world of Archimedes. To understand Archimedes' principle, we must travel back to the ancient city of Syracuse on the island of Sicily around 287 BC. This was a world of philosophers, astronomers, engineers, and mathematicians. And among them stood one extraordinary mind. Archimedes was not just a scientist. He was a genius centuries ahead of his time. He designed war machines, studied geometry, developed mathematical theories, and created inventions that amazed the ancient world. Some historians even consider him one of the greatest scientists in human history. But one problem presented to him by a king would become his most famous scientific breakthrough: the king's golden crown. According to legend, King Nero II ordered a magnificent crown made from pure gold. But after receiving it, the king became suspicious. Had the goldsmith secretly stolen some gold and replaced it with cheaper silver? The problem was difficult. The crown could not be melted down without destroying it. So the king turned to Archimedes for help. For days, Archimedes struggled to solve the mystery. How could he determine whether the crown was pure gold without damaging it? Then came the moment that changed science forever. The Eureka moment. As Archimedes lowered himself into a bathtub, he noticed something strange. Water overflowed. The deeper he entered, the more water spilled out. Suddenly, he realized something extraordinary. An object placed in water displaces an amount of water equal to its own volume. And at that instant, the answer became clear. If the crown contained silver, it would displace more water than pure gold of the same weight because silver is less dense. Legend says Archimedes became so excited that he ran naked through the streets shouting, "Eureka! Eureka! Eureka means I have found it. Archimedes' Principle Explained." So what exactly is Archimedes' principle? It states, in simple terms, any object submerged in a fluid experiences an upward force equal to the weight of the fluid it displaces. This upward force is called buoyancy. A rock sinking in water. A wooden block floating. A ship floating despite its enormous size. This explains why some objects sink while others float. If the buoyant force is greater than the object's weight, it floats. If the object's weight is greater, it sinks. Simple, yet revolutionary. One discovery continues to shape civilization. And it all began with curiosity. A simple observation. A bathtub. A brilliant mind willing to ask questions. Science often changes the world in unexpected ways. Sometimes the greatest discoveries are hidden inside ordinary moments. Archimedes looked at overflowing water and saw a universal law of nature. That is the power of human curiosity. And perhaps the next Eureka moment belongs to someone watching this video right now. What other ancient discoveries changed the world? Like, comment, subscribe. Honestly, understanding this made me look at everything from a pool float to a cloud differently. If this explanation clicked for you, do me a favor and hit that like button. It really helps the channel get this science out to more people. And tell me in the comments, what's the most surprising place you've seen Archimedes' principle in action? If you want to dive deeper into the physics of everyday objects and science discoveries, check out on the next videos. Thanks for watching. I know you have been waiting for me. Welcome to the World Documentary Series, where we bring you education, discoveries, histories, innovations, and developments. In the previous video we presented on how Israel achieved statehood. Kindly hit the subscribe button and like the channel for subsequent series on this platform. I am Brian. This time, I will be presenting on Archimedes' principles. Ever wondered why a massive ship floats, but a tiny pebble sinks? It's not magic. It's science. And understanding this one principle could literally change how you see the world around you.